So this is a merit level question because talking about find the values of the decreasing, but actually because it's asking for the value of decreasing, that means you will have to find the maximum minimum. Plus, to differentiate this, you need to use the product rule. Therefore, it's a merit level question because the product rule, the quotient rule, if it just differentiate, then it's an achieved question. But you will, if you'll have to do something with that differentiation, then it's moved to a merit level. So now we will, because it says decreasing, that means we'll find maximum and minimum. So this word, this one here, means you want a max or min. Max and min. So now we will differentiate first. So y dash, and because it's product rule, so I'll use my work on the side. Please don't skip this step because it's quite important. It will prevent you from making mistakes. 3x squared times ex plus ex, which is g dash times f. Okay, and now to make it 0, so we'll make it equal to 0, and because we want to work on something, so I'll have to factorize in here to find the answer. So I'll find ex is the common factor and x squared also the common factor, so I'll have e square e to the power of x is a common factor, left is 3 plus x equals 0. So the first one, x square ex equals 0, that means x is 0, and or x equal negative 3. So you've got two values of x. We need to find which one is maximum, which one is minimum. So I'll have to double differentiate, and because I double differentiate also, it has another product rule in here involved. So I'm going to do the first part, because the second double differentiation in here, if you see, is just the same thing. You can apply, or you can double differentiate when you factorize it. I will double differentiate when I factorize it, it's easier. Oh, it's actually the same, so I'll just differentiate this. Okay, so I'll do the first one, f equal 3x squared, so f dash equals 6x, and g equal ex, so g dash is e to the power of x. So I'm just going to substitute the first one, that first differentiation here. Let's double differentiate that. It's 3x squared times ex plus 6x times ex, plus I'm going to rewrite that again because the double differentiation of ex x to the power of 3 is the same thing. We already have it from the first step. Okay, now you can simplify if you want, like this one here will give me 6x squared e to the power of x plus 6x e to the power of x plus x to the power of 3. Now if I substitute 0, I'll end up with 0 because everything is multiplied by x. And if I substitute negative, this one will get, so if I do y double dash to 0, it will give me 0 anyway, so that's a point of inflection. So if I do double dash y double dash to negative 3, you don't need the value, you only need to work out, you can substitute and find the value, but you only need to work out the value. So this one give me positive, this one will give me a negative definitely, and this one will give me negative. So I think overall will be a negative. So negative 3, x to negative 3 is a max. Just double check in the calculator. Okay, because it's a max, so all you need is just, this is a maximum point. Negative 3 is your maximum point, so it's decreasing anything after the maximum point because that's your maximum in here. So therefore the curve is decreasing when x is greater than negative 3.